In this lecture, we're going to talk about pulse and blood pressure. So in your body, your pulse is just a pressure wave of blood, and you can monitor it at pressure points in your arteries where the pulse is easy to palpate or feel through your skin. The pulse averages for people between 70 and 76 beats per minute at rest. Obviously, that's a range. It could be a little more than that or a little less, but typically if your pulse is between 70 and 76. Your pulse can be palpated at many different places on your body. These are places where arteries are pretty close to the skin, so you can feel it through your skin. So that includes the superficial temporal artery, facial artery, the common carotid artery, the brachial artery, the radial artery, femoral artery, popliteal artery, posterior tibial artery, and the dorsalis pedis artery. Most of the time when you take someone else's pulse, you take it at the radial artery. And when you take someone else's pulse, you always want to take their pulse with two fingers, your first and second finger, not your thumb, because your thumb has its own pulse. And so sometimes if you're trying to count someone else's pulse with your thumb, you might be counting your own pulse. And then another really easy place to find your pulse is like the common carotid or the facial artery. Another measurement commonly taken is blood pressure. So this is a measurement that health professionals take in one of the large arteries. And like we talked about before, there's something called your systole and diastolic pressure. The systolic pressure is at the peak of ventricular contraction. So that number is going to be the highest number, and it's on top of the fraction that you write. And the systole number is high because the ventricles are fully contracted. The diastole number is when the ventricles are relaxed, and so that gives you the bottom number. And so, for example, you always write systole first and diastole last, and it's measured in the units millimeters of mercury. Pressure in blood vessels decreases as the distance from the heart decreases. So when people take blood pressure, they typically always take it in the same place. So you can either do it with a blood pressure cuff on your arm. There's also a blood pressure monitor you can put on somebody's finger. And pressure drops the further blood gets from the heart, right? So when the heart contracts in the aorta, blood pressure is very high. And then as it moves through arteries and then to arterioles, it gets a little bit less, and then it decreases more as you move through capillaries, venules, and veins, and then back to the vena cava, which are the two blood vessels that return blood to the right atrium. When we take blood pressure at the doctor, typically we're going to use the brachial artery. That's the one that's on your arm. And so in that vessel, normal blood pressure is about 120/80 over 80, 120 over 70. Once you've put on a blood pressure cuff, the first thing that you do is add enough air to the cuff to completely cease the blood flow in the radial artery. So that blood is completely stopped for just a moment in the brachial artery, and then you cannot feel the brachial pulse. Next, the person who's taking blood pressure is going to listen with the stethoscope for the sounds of blood re-entering or starting to move again through the artery. And so if you're taking someone's blood pressure, you have the cuff all the way on so that blood is not flowing through that vessel, and then you listen to the blood vessel, and then you slowly let air back or out of the cuff, and as air leaves the cuff, blood is going to start to move through the artery again. When the blood starts to move through the artery, it makes quiet like whooshing or tapping sounds, and that's how you know what number goes on the very top. And it should be around 120 millimeters of mercury when the cuff is being just opened. As more air is left or let out of the blood pressure cuff, there will continue to be sounds until the blood vessel is all the way open, and then you'll stop hearing sounds. When the sound stops, that's the bottom number on the pressure gauge of the blood pressure cuff. Blood pressure is often just referred to as BP in this equation. So we're going to use blood pressure, and we're going to calculate what it is what affects it by looking at cardiac output and then also peripheral resistance. So that's the amount of friction that blood encounters as it flows through blood vessels. So a person can calculate blood pressure by multiplying cardiac output, which is the blood being pumped through the left ventricle per minute, and multiply that by peripheral resistance to get blood pressure. Much like pulse and all those things, blood pressure is affected by several different things. So neural factors can affect this, right? So this is anything that comes from the nervous system, specifically the sympathetic division. It can also be impacted by renal factors. Remember, that's what your kidneys do in part, is to regulate blood pressure and things like that. And so your kidneys can change blood volume, and they also produce a hormone called renin that can change blood pressure. Temperature that you're experiencing can also impact your blood pressure. So heat has a vasodilating effect, meaning that blood pressure will go down. Cold has a vasoconstricting effect, meaning blood pressure will go up. And there are various chemicals that can decrease and increase blood pressure. And then someone's diet, so like if you have a really high sodium diet or something like that, that can impact your blood pressure as well. So just like everything else with your heart, it can be impacted by a variety of things, including like blood volume and regulation from your kidneys, exercise, posture changes. Your blood pressure generally is higher when you're standing than when you're laying down. And then chemicals like hormones like renin and things can impact your blood pressure, as can blood viscosity. So like if your blood is thicker because you've been at a high elevation, or if you're on a drug like Procrit or something, that can increase your blood pressure. In humans, the normal blood pressure is, of course, a range between 140 and 110 for the top systolic number, and then between 80 and 75 for the diastolic number. If someone has hypotension, that means they have low blood pressure and they have a low systolic number that's below 110. It's often associated with illness. And then hypertension is when you have a high systolic number, about above 140 millimeters of mercury, and that can be dangerous if it's chronic. Your blood pressure will go up if you're exercising. That's normal. But if it's always above 140 when you're resting, then it's a good time to go in and see a doctor.